With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so the question is a uniform circular disc placed on a horizontal rough surface has initially a velocity of v0 and angular velocity omega naught as shown in the figure. The disc comes to rest after moving some distance. That means at that time the velocity and angular velocity v0 and omega naught is 0 after moving some distance in the direction of motion. Then the ratio of v0 and omega naught is, we have to find out the ratio of velocity and angular velocity. As you can see in this diagram, there is a sphere which is moving with the velocity, linear velocity v naught, and with the angular velocity omega naught, and surface is rough. That means there is friction between this surface and this sphere. Now we know that when this sphere is moving in forward direction, that means it is doing translational motion as well as the rotational motion. So first I am going to write the equation for translational motion. The equation for translational motion for translational motion. For translational motion, the equation of motion is given as v or u equals to v plus at. This is the initial velocity, this is the final velocity, a is the acceleration, and t is the time. So now this value is 0, so 0 equals to v naught. Suppose the final velocity is v naught. Now this is moving in this direction and friction is in this direction. That means friction is happen this direction and motion in this direction. That means acceleration is a negative because this is retarded the motion, and for retarded motion acceleration is basically deceleration. So the value of a is basically minus total force, that is frictional force, upon total mass, that is m. So the value of a acceleration is minus f upon m, because the force and the motion both are in opposite direction. So the value of a is minus f upon m t. So from here the value of t is coming out to be mv naught upon f. This is my equation first. Okay, now this block is also doing the rotational motion. So similarly I am going to write equation of motion for rotational motion too. For rotational motion, in rotational motion the velocity is given as angular velocity and the acceleration is given as angular acceleration. So the equation can be written as omega equals to omega naught plus alpha t. Omega is the final velocity, omega naught is the initial velocity, alpha is the angular acceleration, and t is the time. Now we know that torque is given by torque is I alpha. So from here the value of alpha is torque upon I, and torque is also given as force into perpendicular distance. So from here I can write torque as force is acting on this sphere is frictional force into perpendicular distance is, suppose the radius of this surface is r, that means perpendicular distance is r. So torque is given by f into r. So I can write omega is 0. Okay, this is 0, which is equals to omega naught plus value of alpha is tau upon I is the moment of inertia, into t, and moment of inertia of sphere is given by mr square by 2. Now putting all the values, value of moment of inertia, that is mr square by 2, value of tau, that is torque, which is f into r. Putting the values, we will have 0 equals to omega naught minus, this also comes in minus, okay, because motion in the different direction, so this sign is changed by the minus sign, so it is minus, and the value of tau is r into f, rf upon value of I is mr square by 2, mr square by 2 into t. Further solving this equation, we will have the value of t, that is coming out to be, the value of t is omega naught, it is mr omega naught upon 2f. This is suppose my equation second. Now we have the time for rotational motion as well as for the translational motion. So I will equate equation 1 by equation 2 because both equation are of time. So from equation 1 and 2 I can write from 1 and 2, from equation 1 and 2, value of t is mv naught upon f for translational motion, and for rotational motion it is mr omega naught upon 2f. So the value of v naught upon omega naught from here is cancel out, ff cancel out, so it is r by 2. The value of v naught upon omega naught is coming out to be r by 2. So let's check the options. The first option, which is r by 2, is the correct option. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.